So in terms of urgency, I would say that there's two big things that have changed in computer vision in the recent years. First of all is how we approach computer vision, and the other one is advancements in transformers. Let's start with the first one. Let's think about what is a computer vision model and what does it require. So let's say that we are trying to detect a face. Why not? That's what we have in hand. Let's use it. We have a set of images with faces all labeled, which means that they have a bounding box around it. So someone needs to go and draw these bounding boxes. And that's the information that we give to our model. So imagine at the bottom, let's say that's where we input our images, and at the top, that's where we actually get our answer. Like say, like there's a face or there's not a face. What we start passing like all the images here, when we are training the system, what's going on is that we are creating some set of intermediate features. Those, after passing like a lot of different examples and a lot of different faces, all with their respective bounding boxes, what we would see is that it's starting to learn some sort of intermediate features. What would they be? Like the eyes, the ears, the nose, the mouth. And to be 100% accurate, this is not what the model would learn, but it's going to be some sort of intermediate feature that, thinking it this way, like that's the way that we humans create the visual features, but the model is going to do something very, very similar. So that's the classical way. We need a lot of data in order to train the model. Why? Because it needs to create all those intermediate features in order to actually get a response, get a detection. Is there a face or there isn't? So what's the new advancement? In recent years, what we've seen is that there's quite a lot of what's called pre-trained models. What's a pre-trained model? A pre-trained model is a model that already has been trained to detect a wide range of objects. Let's say a human, a car, a dog, pretty much anything. Like one of the most common data sets, just to give an example, is called Coco, and it has 80 different classes, so 80 different objects that it's detecting. When it's training, what it's doing is it's learning a very diverse set of intermediate features. So now, if we want to detect a face, we don't need to start building them from scratch. We already can use the features that they have trained, and we need a number of labeled images that's much, much lower than what it once was. Imagine that if before we needed like something like 10,000 images, maybe now we need like 1,000 or even less. I mean, those numbers vary greatly in terms of the application and so on, but like 10x reduction, 20x reduction, that's the things that we have observed in real world scenarios of leveraging pre-trained models instead of starting to train from scratch. Because building those intermediate features takes a lot of data, and leveraging those, it's something that not only saves us a lot of time, but a lot of money, because building a big data set is very costly. And yeah, that's one of the big things that maybe urge the business owners in order to adopt technology, because now it's not only cheaper, but faster. So you can prototype, design, and see the results a lot faster, which I think is like pretty much what every business owner was. And the other one is transformers. We all heard about ChatGPT, and the technology that powers it is called a transformer. What a transformer is, it's effectively a deep learning block, to call it like that it understands relationships very well. This is normally called attention. Let's put first a quick example with text. Like when we are talking about text and we talk about attention, it means that it knows which word is related to another one. So let's say, like, if you're talking about like, Tim is going to the beach, he is tall, something like that. You would know that he and Tim are referring to the same entity. Then for when we're talking about images, what we have is a visual transformer. What what that empowers, or what that allows, is that we also have this sort of attention. So let's say that we detect some eye. It would know that if the model has been trained and everything, that it would require to have another eye in order to have a face. So there are certain modifications that can be done in order to understand very well and to detect in a more accurate way. So let's recap. The first one, it's about the new ways of training, which are cheaper, faster, and yield results in a cheaper and faster way. And the second one, it's that we now have the transformers, the building block of ChatGPT, now powering also computer vision models. And what that yields, it's better performance and more accurate models. They don't only allow a gradual improvement, there's also a new set of things that now are possible that they weren't possible a few years back. Like, let's put, for example, now what we could do is like get an image and get a very accurate caption, like a description of what's going on in the image. That has a very wide range of capabilities. It could be understanding what sort of data do you have in your data set. It could be extracting certain insights from images that your users give you. That's one of the ones that we could talk. Another one, and one of my favorites, is a visual search. We all have seen Google Lens, which is that we take a picture and we give it to Google, and it tells us what's similar to it, and if it's a product, where you can buy it, and things like that. Imagine that, for example, like an e-commerce site. If I take a picture of my sweater and I'm trying to find something similar, like then I can do something like that. But it doesn't need to stop there. Imagine it could be like for the pattern, the color, it could be about the style of the zip. It could be many different things. Like, it just depends what the client deems to be the most important for their users. But those are all things that are empowered by using computer vision in software and tech companies. Aside from that, you could get like something a bit more immersive and realistic. One of the technologies that I find quite interesting is like for VR. It's not only for VR, also applies for AR or augmented reality. What you see is that you need to have a very good detection of where your goggles are in space in order to project things into it. And these things, like even like with the latest virtual reality headsets, what you see is that they use visual features in order to locate the images and see how it's actually moving. So it's not only accurate, but it's very, very fast and very precise. And maybe it's like one of the less well-known features of computer vision by the general public. In general, there are other ones like quality control, inventory management, traffic analysis, even medical diagnosis. What I feel is interesting is like everyone can see, so everyone can kind of get of an idea of what could be a good idea.